All right. So look at this today. This lecture on classes and objects is what we'll be reviewing here. Go ahead and go into here. Go ahead and shut this down and shut down any other stuff that's going to ping or make noises. All right. Okay. So this circle class here, the code for it is here in the slide here. I'm going to go ahead and put it also up here, and then I'm going to 50-50 this screen to kind of go over some of this stuff here. We've got this circle class here that we've got where we've got two attributes here inside of the circle class. We've got this circle count for how many circles we have, circle objects are created. Then we have this attribute called the radius, which is the radius of the current circle. So we've got that piece there. And then what we're going to use for the static variable, and this variable here is static because it is available as a attribute outside of the class. So you can, outside the circle class, just call it without calling an object. So you're able to actually store the number of circles in our universe of circles in this attribute, and it's going to be available at any time that you want to call it without having to call it through a circle object. So that's what we'll see in how this is called and referenced. So that's the purpose of it being static, so that it doesn't have to have an object. A non-static attribute needs an object. So this private double radius, this radius refers to a circle object. So you have to have a circle object in order to take its radius and look at its radius. You don't need a circle object to look at the overall class attributes like this static attribute of circle count. So
can you explain a little bit what the this dot means? I was a little bit confused on that in the
textbook. Yeah, we'll definitely get to that for sure. That's a great question as far as clarification, because that is a really weird nomenclature. I tend to overuse it, so you're going to see a lot of this, and then I'll call things that, just because I like to work with this and that. Other people use the other as another example of that kind of reference, or the variable naming kind of thing. So yes, I will definitely go over that. This dot kind of nomenclature that really refers to the current object you're working with. So that's how that should be thought of as far as a concept. You want to think of that as the current object that I'm working with. This dot, say radius, and it'll be the radius of this circle that I'm looking at right now. So that's how that would work in this particular example of the circle. So one example of that over here in this identify the static variable is circle count, and where it's available is pretty much anywhere inside of the class. It's also available outside the class. If you were to, or without an object, you can do a circle count at any point in the class as well.
And what happens if you didn't have this dot and then you just referred to it as radius?
It depends where you are. So if you are referencing a radius from a object inside of the class, it will probably refer to the current object's radius. So but it could be ambiguous. And that's why for me, I like to explicitly, anytime that I'm trying to refer to the current object that I'm working with, I almost always put this dot radius, just to make sure it's clear to me that it's this radius, not that radius. And so that's why I'll tend to do that, or I'll call it that radius or other radius, that kind of thing. So yeah, it's best to kind of explicitly label your objects and the attributes per object that you're working with. So in this case, if this radius that we're passing in, and this is why this radius doesn't have this dot radius, so we're coming into here in this circle constructor here. So let's go ahead and jump into this one and we'll go through the different pieces here inside of this circle constructor. So if we want to make a new circle, we have to, we're going to take in a variable called radius. We could also call that radius or new radius, and that would kind of differentiate it from the other variable a little bit. So sometimes it's good to name these things like other radius or that radius. But in this case, we haven't, because this is the best practice kind of standard is to just name it the name of the attribute. Again, I think that's a little confusing. So sometimes I will actually go that radius or other radius. This is not an example that I particularly wrote up. It's a generic example of a circle class. So this is why this is, but it is a standard way of programming Java. So you're going to see this a lot out there in examples in the real world. So you should be able to read this too. So this double radius here is going to take this radius value. It's going to increment the number of circles that we have because we're creating a new circle. So it's adding one to the overall circle count. And you don't need to say this dot circle count because it's not referring to an object. It is the overall circle count. Because this is a static variable, we're saying we want to increment and add one. So the plus plus is adding one to the count of circles and how many circles we have. So we're doing that. And then we're going to go say, if the radius is greater than 0, then we're going to say this circle's radius is equal to radius. Otherwise, this dot radius equals 1. So if it's a negative number, we can't have a negative radius. So we're going to set it to 1 always. That's what this is saying. So if we are passed in a -5 into this circle constructor to create a new circle, then we don't want to have it be a -5 radius. We want it to actually be 1. So we're going to set the radius to 1 based on the fact that we want actual positive numbers for our radiuses for all of our circles. That's kind of our rule for creating circles. That rule is kind of built into this constructor. So a lot of your constructors are going to be where you have these rules or constraints or tolerances or numbers that you have to fall within for things like a radius or other attributes of those actual objects. So in this case, we don't want negative radiuses. That's the rule. Here's how we apply that rule. We put an if else into here. So we're always going to set it either to a positive number radius that is passed to us, or we're going to set it to 1 based on if it's a negative number or 0, then it's going to be 1. We're always going to have positive numbers for radiuses here. So that's the constructor. The next piece is this get circle count. This is semi-redundant because this is a static variable. We could actually get this inside of the class just by calling circle count and grabbing that. But this is the accessor if we want to get that outside of the class. So if we're outside of the circle class and we want to get the circle count in another program, we need to have a way to get to that attribute. Because it is a private attribute, we would not be able to get to it without having this accessor here or getter. So this getter is allowing us to get that from outside this class. So when we look at another program, we're going to have another program that we have that is a swap driver. That swap driver doesn't have access to this circle count because it's not in the same class. It's another class out here that's going to call the circle class. It calls the get circle count to get that circle count. So that's why we're making this accessor here, because we've got a private variable here. Even though it's static and is available inside of here without an object, we can't just call it from outside of the class. That's what that private refers to. So this is kind of the variable scope here, this slide here that talks about static variables. So where are static variables are class variables. So they're declared outside of all the methods. They're at the top there, the static variables, like the static variable circle count. Where can we use it? Anywhere in the class or in other class if also public. But this is not public, so we can't use this circle count inside of another class. If we made it public, we could actually use the circle count. As long as we have a compiled circle class, we could use circle count in another class. So that's one way. You wouldn't need an accessor or a getter in here for circle count if you had it be public. but sometimes you don't want to do that with certain pieces of information. Here, this circle count is pretty innocuous. We don't really care. This is, it's not government secrets. It's not a password. It's not a number of customers that we have or donors we have or something like that, that we would kind of want to protect. This is a number of circles. I don't think anybody's really concerned about the number of circles that are in existence. Now, if this were something bigger, if this were a thing that you wanted to keep more private and didn't want to say that, say this was a vaccination count and you didn't want this available to just anybody, but you only wanted those who you would allowed to, you'd make it private. That's the kind of thing, a vax count, let's say, if you were getting vaccinations and you wanted to keep that information private for HIPAA reasons or something like that, which is some governance for medical information and the privacy thereof. So if you wanted to do that, you would probably make this private, a vaccination count, that kind of thing. So we've got that. We've got this instance variables or these attributes. So this is an instance variable, the radius attribute in the circle class. They're declared outside of the methods, again, at the top, before you have any of your methods or your constructor. And then their after static variables are the instance variables of the class or attributes of the class. Then you've got, they're used any non-static methods or in any static methods when another object has been created. So you can use these things inside of any non-static method if you've got a object that you're working with. All right. Parameters. These are inside the parentheses. That radius there inside of the circle constructor here is a parameter that is being passed in as an argument. So then we've got local variables. So these are the local variables. If we had anything in here in the method, this would be a local variable that we would be working with. So we don't have any in any of these. I think the closest thing would be your math.py, although that's a constant, not a local variable. I don't see anything as a local variable. Only local variables we have are this temp x and y here. So these are this temp x is or temp is the only interim variable or local variable that we would have, and this is local to the swap ints method. All right, so if we have this swap driver item here that we're working with, let's go ahead and open that, and we've got this swap driver file here. Predict the output of swap driver. Let's go ahead and take this class and let's compile it. And that should work just fine. All right. And then now let's go ahead and do this swap driver. We're going to compile this one as well. And then we're going to run this. So when we're doing this, what we're going to get here is we're going to swap these two integers. So we've got two integers, 7 and 4, that we're going to set up out here. We've got them set up as 7 and 4 out here. We're going to say A equals 7 and B equals 4. Then we're going to do circle.swapInts. So even though this circle class doesn't have anything to do with integers, we've created a method within this circle class called the swapInts. What it's going to do is it's going to swap the values between X and Y, which we're passing into it. We're also calling them A and B outside in the swap driver, because that way we can differentiate which ones are which. So inside of here, what we're doing is inside swapInts, we're passing the two values in, whatever parameters we're passing in to this as arguments inside of this swapInts method, we're going to take those. We're inside here, we're going to say inside swapInts, swapping integers X and Y, or 7 and 4. And then we're going to take this and set X equal to Y after we've set temp equal to X. So temp equals 7 in this case, then X equals 4 and Y equals 7. Then we're going to say finish swapping X and Y, and we're going to be done with those pieces there. So then we're going to come out to here and we're going to say after swap, and we're going to say A equals A and B equals B. So these two values that are here. So what we're going to notice though is that we are not going to actually get that particular piece, because if we look at this, We've got before swap 7, 4, inside swap, swapping integers 7 and 4, finish swapping 4 and 7. After swap, A equals 7, B equals 4. Why is this? This is because of the scope of these variables. So that A and the B are that are outside in the swap driver are never getting changed. That is a different set of variables because it's in the calling method. You're not actually affecting that when you're sending those values, and that's passing those values in to that X and the Y. The X and the Y get changed inside of the method, and that's why we're doing here inside the swap ints, we're swapping those integers, those values do change. So the X and the Y do change there, but they never cascade back up. They're stuck scope-wise inside of that method. This is a really important concept to understand. So make sure you're getting why these things are not changing. This X and the Y are not the same as this A and the B outside here. So the A and the B are outside here at the top of this method in the main of the swap driver, but they're never going down. The values are being passed to X and Y. So X and Y assume the values of those two pieces. The best way to look at this sometimes is through a memory stack diagram. And if we were to look at that in that way, what we would find is that we would have, let's go ahead and show my notes here. Yes, okay, over here. So what we would have over here is we would have in here our A as 7 and B as 4. And then we would go into here, and this would be the main method. We would have this all in one piece here. Then we would have inside of here, we would also have our swap ints. And we would have inside of here an X value, which is 7, and a Y value, which would be getting the 4 in here. Then when we change those, we would get this to be equal to 4 and 7. And we'd also have a temp value here, which would be equal to the 7. So that's what the memory stack diagram would look like. So again, that's key to understanding what's going on here, is that you're actually having this A and the B outside, and then the X and Y interior to the swap ints method, and they're getting values passed into them, but they're never changing the actual A and the B values because those are separate variables in memory. And so that's a really key concept to start understanding. I think we examined this before in some of the other pieces when we were talking about methods originally, but this is doubly so important to understand when you're talking about objects, because the object pieces, you need to make sure that you're understanding what attributes you're changing. If it's the attributes of an object, the object attributes will actually carry back and forth. So now we're coming into this one, and we're going into swapping circle radiuses. So the next piece here is looking at this circle radius. We're going to take circle first. We're creating one circle called first. Then we're creating a second circle called second. We're going to, for the first circle, we're going to create a new circle with the constructor call here, new circle, and we're going to pass it 7. So the 7 is the radius of this one, just like we did with the X and the A and the B and the X and the Y. We're going to do the same thing with these radiuses. So second equals new circle sub 4. So what's our values here? When we run this, we're going to do this. And then we've got this swap circles item that we're running inside of here. Inside of here, we're going to pass circle 1, C1, and circle 2, C2. The difference here is that when we're referring to objects, we're actually passing the references to these objects. So these will actually change the attributes of the object. And we're talking about the same object because we're pointing to the same object inside of memory. So the memory stack diagram for that section would look more like this. We've got this main, and we've got the items here that we're going to add. Let's go ahead and add these in here. Circle 1, and we've got first, and first is going to point to this item over here that is a circle, and we're going to have a circle with radius of 7. Then we've got second in here, and this is going to point to an object of a type circle, and it's going to have a radius of 4. And that's the difference there. So when we come into here and then we go into here and we're going to say first equals first, 7 and 4, and then we're going to do swap circles with first and second being passed down to here. So this C1 and C2 point to, if we had these, we'd have C1 and C2 down here, and they would point to 1, and C1 would point to the same thing. And what I'd really need here is a arrow that comes over here all the way up to this radius. So it's going to point to that same object up there, and it's going to point around. So this is where you'd really need to do this as more of a diagram with an arrow that could actually link out to the arrow here that is in first. So, but that is a pointer to the, and it's going to point to first. And then C2 is going to point to second. So that's the same object. So when you affect C1 and C2, you're affecting the object that is first and second. So over here, when we're doing this, we're going to actually, inside of here, do the swap radius here. We've got this double R equals C1 dot radius. So we've got another variable here, C1 dot radius. So this R equals 7. So that R is equal to 7. We're going to have that as 7 in here in the memory stack diagram. Then what we'd have over here is C1 dot radius equals C2 dot radius. So that's where we're going to change this radius to be equal to 4. And for a moment right here, if we were to take a snapshot of this during the call of this at line 56, we would get this as 4 and 4 in the memory stack diagram. C2 dot radius equals R, so we're going to say that equals 7 now, and R equals 7 too. So this would be the final memory stack diagram after the swap has been performed. Over here, we're coming out to here, and we're going to print out the program created 2 circles. So we've only got 2 circles in existence, first and second, and that is pulling in the circle.getCircleCount, and that's referencing the attribute that is a private static attribute inside of the circle class from the swap driver class out here, going using that getter to get that attribute and displaying that. So this is kind of a key concept to understand how to use these getters to get the attributes out from the class and out from another class if you're in a different class than the actual class that is tracking these items. All right. So now that we've gone through that, let's go look at this guy. So if we're looking at this color class here, we're going to be looking at this in the lab a little bit more in detail, but this is the UML diagram, and I think we went over that enough last class that I'll leave that to you. If you still are having questions about that, message me about that. There's more on that example in the UML diagram, how to read it. So this is the UML diagram. We've got the constructor method here. This one has 2 constructors. When we call it, these methods are going to be called the same thing as the class name. So we've got 2 color constructors. One has 3 attributes that we're going to pass it. The red, green, and blue components or attributes inside of here are all integers. We're going to pass 3 attributes in, and we're going to create a color based on those 3 attributes. The other way we can do this is we can base a color based on another color, and we can make a copy of the color. Again, this is an immutable class, so you can't change these colors. You can only create a new color based on a copy of the other color. So inside of here, that's the case. Inside of this one over here, we've got a mutable object here, this point. So this point is allowing us to change the X and Y values. So we've got a setter for X and a setter for Y. So we can change these actual values of that object inside of this one. So this point object is a mutable, or one that you can change the actual attributes of. This one, there's nothing that says set red, set green, set blue. So there are no setters in here. So this is an immutable class. We can't change those attributes. We can only create a new circle object based on new attributes, or a copy of the current attributes. So these are the other ones. We've got the accessors, the getter pieces here. In here, again, examples over here would be your get X, get Y, your setters, set X, set Y, and then your object methods such as equals and toString. So you've got a toString that prints out some string that talks about your object. Maybe says that you have a point at X comma Y, and it would print out the X and Y attributes, and that would be the toString. Same here for this color. Your color is, and maybe it has a red and green and blue values, and it would put those in parentheses. That's a real common way to display that, is 0, 5, 20, that kind of thing for a red, green, and blue attributes. All right. So the color and the point here, these are, if we look at the constructors, again, you've got these, this point one has one that has no attributes in here, and then it would get set at 0, 0. This other one is an explicit one where you're actually creating one with an X and a Y by passing those in. And this one has a third one, which is an overloaded third time you're creating a constructor from a point from another point. So you're creating a point based on another point. This idea of a copy constructor is what we call those. So you're going to have a lot of these in the classes that you create, where you're trying to create another class based on a class that you already, or an object that you already have. So that's what we call a copy constructor. You're going to make a copy of this object based on the other one, because you don't want to mess with the original attributes in the case of the point, because that's a mutable class. You could edit the attributes, but maybe you don't want to. Maybe you're trying to copy it. Basically, that's what we call the copy constructor. So you don't have to have a copy method. You're just making a copy using the constructor by passing it the other value into there. And that's, again, so that you don't mess with that existing point. You have another point that is at same location, probably X and Y wise, but it's another point that you're kind of laying on top of that point. So there's different times where you're going to want to do that versus actually editing that first point and taking the X and Y value and changing them inside of that. All right. So this credit card design, we're going to get into that in next week. I've got a more fully fleshed out example of that. You can take a look at that too. I've got a video on that too. So if you're having questions on that, you can take a look at that one. I typically have not gone over this as much because I've now started to talk about this a little bit more in class. All right. Let's go ahead and get into this lab though, so we can get into here. We've got this color lab here. This is, again, this will be due in Auto Lab tomorrow evening. I will be counting that into the homework grading, not as a lab grade. So make sure you put that in there. Word of the day was already given. So make sure you put that into Canvas, and that'll get counted into the 10 points that this is going to be worth. So this is kind of like one homework problem worth. And again, this 10-1 through 10-3 are going to be due next on the 19th, Monday. They will be an actual in-class quiz grade, because again, I want to give you the opportunity to improve that grade too. And that will have a hopefully better balancing effect on overall grading. So make sure you know that. I will put out an announcement for those who may not have been in class today to know that as well. This Lab 20 is just an extra set of exercises. Given that we had the break day, I usually cover this on the break day, or I would have covered the color lab on the break day and then covered this lab today. But this one is less necessary. It's a lot of fun because it actually works with building something on screen and you can actually see an object being built. So it is kind of more of an interesting exercise if you want some more practice with objects and building objects and doing some things graphically. Feel free to do that one. I'm not collecting it for any kind of grade. Again, this is just for your own curiosity and actual extra practice. So that one's there for that purpose. All right. Let's go ahead and go into this color lab and then we'll take a look at this. So for this lab, you're going to create a class named Color 149. Java already comes with its own color class. You can look at the documentation and source code, but we're going to create a variant of that class. This one is going to be a little bit different than the other color class. So the typical color class has a lot more attributes. We've got all of these constants in here, and we've got a bunch of different constructors in here. I think ours is going to be a little bit more simple in the constructors we have. So what we want to do is we want to download this main.java. I'm going to download this and put it into my desktop. Actually, no, I don't have my in-class one in there. So let's go ahead and just put it to the desktop. Save this one there too, download file. Put it to the desktop. Let's go ahead and move it from the desktop. And we'll move it into our CS149 in class here. Then I'm going to open up JGrasp and I'm going to go into here and grab my color 149. I'll close these two for the circle pieces, and I'm going to grab this main.java. All right. So what do I want to do with this? I want to take this, and inside of this class, I'm going to be looking to do a few different things. You can run this from the command line. You can also instead of running it from command line, and I've given you how to run it from command line, but you don't have to do that. You could actually run it from within JGrasp because we've got this run arguments here, so we can run it from inside of here. So we can output this to the output dot. So if we did this as output.html in that side of there, we could actually run this. So let's go ahead and compile this guy. This compiles just fine. We'll compile this guy. And then we want to run this guy. And this is going to produce out a file here. Let's go find this file. Inside of our CS149 in class, we're going to have an output.html, hopefully somewhere. I don't know if it actually created that. No, it did not. So let's go ahead and run this outside of here in our command line. All right, let's go to CS149. Actually, desktop first. All right, and then we can go Java C, color 149.java, Java C main.java. Then we'll go Java main output to output.html. And then we can open this output.html file inside our browser here. So this is going to look like this. It's just going to be a bunch of black squares over here because we haven't done anything, and everything is, all the colors are 0, 0, 0, 0, 0, 0. So absence of color, all zeros is black. Full all colors is white. So FFFFFF in hexadecimal would be the representation of that, and it's going to be white. So that's how colors work within HTML. So this is using an HTML page to kind of represent these colors. And as we're going to keep recompiling this piece, and then we're going to get this to change a little bit. So let's go back into here. Let's look at what we're trying to accomplish with this lab here. So inside of this lab, what we want to do here is we're going to come into here and pull up our 149 class. Make sure you come into here and edit your name and the date and all that. You may need to restyle this. I think this is styled for the old style here where it's got the 3 or 4 spaces instead of 3. So in order to pass check style, you'd have to pass it over to, I think it's going to need to have a lot of work there. Yeah, see, these incorrect indentation levels are going to be all over the place here. So you're going to want to pull this all back into here. I may see what I can do to upload a more current version that has that is styled towards our other style. The other thing you could do is throw this into Eclipse and quickly get it to format the style. Let's pull this back in. That's going to need a second one in here. And some video game here. All right. All right. Save this. I'm probably going to need to come in here and do another couple of spaces in here. Here. Get that right. Here. All right. I think that's good. Okay, so let's line that up to there. All right, save this. Add a space into there. All right, I think that is about it. Yeah, all right, let's try and check style that. All right, still got a few. Oh, yep, up here. A couple of those kind of issues. Block comment should be separated. Probably all of these are that. All right. And I think I got a bunch of these too. I'm not going to go ahead and let's go ahead and disregard that for now. I'll go ahead and save this. Let's go ahead and run this. Today, we're going to do these pieces. So we need to look at these different pieces. All the constants have been defined. And what we're going to need to do is create these pieces that say make me here. So we've got these constants of black, red, green, yellow, blue, magenta, cyan, and white. These are the typical colors that we have inside of our palette within the HTML world. So you can see here black 000, blue is 00255, and 255 is the max color number we're going to have. So what we want to do into here is we're going to create this constructor here. And we want to make note, this constructor creates a color 149 object that is specified with a RGB, red, green, blue component values. If a component value is less than 0, we want to set it to 0. If a component value is greater than 255, that component's value is set to 255. So inside of here, we want to go if, let's call these in new red equals red component into new green equals green component, new blue equals blue component. Okay, so we're going to create 3 integer values, and we're going to manipulate these to make sure that they're the right values. So if new red is greater than 255, new red equals 255. Else, if new red is less than 0, new red equals 0. So we've got these 2 things that we're doing here to give a ceiling and a floor. That's what we call these values: the ceiling value of 255, the floor value or lowest value of 0. So in order to contain these colors inside of the right values, we've got a ceiling of 255 and a floor of 0. So that's going to allow us to do that over here. Then we're going to want to do the same thing for the other 2 values here too. So we want new green in here and new blue in here. All right. Then once we've got this all good here, we're going to take this and we're going to create a new color based on that. So we're going to want to create another color based on this piece. So we're going to say this dot red equals, and this is the components here are the red, green, and blue values of this object. So this is where we're coming into this object that we're working with. This dot red equals new red. This dot blue equals new blue. This dot green equals new green. Actually, let's do this in here. All right. So this should allow us to make a proper constructor here. Let's go ahead and compile that. And let's come out here and let's rerun our main. Oh, I need to recompile these because they're not in the same Java. Let's go ahead and recompile these. Okay. So now if I go back to this output.html and I refresh this, now I've got this constructor portion working correctly. So I'm constructing a red that looks like red, a green that looks like green, a yellow that looks like yellow, et cetera, down here. And we've got the ability to create actual colors. So when I am running this out here and running these commands of Java C color 149 and then rerunning this main, Java main, and we're outputting it to this output.html over here, I can actually get that piece done. Let's see if I can run this from inside of here. So the other thing you could do is in here, it's printing this out here. So you could always run this and get it over to, yeah, so this is running this and it should actually get the HTML output in here. Let's go ahead and change up and I'll do one more piece of this. So at the end of the day, what you're going to want to do is have this file match this sample output. So there's several different pieces. We're doing a lighten, a brighten, a darken, and a dim. So there's 4 other methods that you'll need to write in here. I'm going to write one of these so that you get the idea of how to do one, and then I'm going to leave the rest for you to do. So we've got this add color here method here, so we can add something to a color. We've got this sub here. So this is the difference between this color and the other color. So we're going to need to complete this one too. And let's go, and this dim is already working here for the dim piece, but we're going to need to do this sub for this subtract, basically a piece from the other color. So that's going to need to be completed for this. So that one's one that we need to figure out. And then instead of returning black color always, we're going to return the new color in here. So we're returning a color 149 object. So we're creating a color 149 object inside of here, just like we're doing in the add. So this subtract is going to be very similar to the add. Let's go into here. We'll go into here and start this one. I'll do this one so that you have a better idea of how this one works. New color here. We're creating that new color, int new red, int new green, and new blue. Then we're going to say new red equals this dot red minus other dot red. All right. And then we're going to say new green equals this dot green minus other dot green. And new blue equals this dot blue minus other dot blue. Okay. New color equals new color 149. And this is how you call this, of new red, new green, and new blue. Return new color. All right. So that's pretty similar to the other one. And that's a pretty simple piece into here. You'll need to do this darken piece and then the equals to make sure they're equal, the lighten piece here, and then the brighten piece here to brighten the color. So inside of here, the subtract color here, we've walked through this. The reason we don't have to do another check for this color, if you were wondering, if you were thinking, well, if I subtract a color from another, maybe that's going to give me a negative number, right? Well, our constructor, and we're doing a new color constructor here, will take care of that for us. So even if our numbers for red, green, or blue are negative or above 255, this will this constructor, because we've already taken care of all of the rules for colors here, when we try and create that new color that's too big in the over 255 range, or it's too low in the negative range, it's going to constrain it when we create that new color. So we don't have to do another set of checks here. We can just do the subtraction and then be sure that it's going to work. So if I do this, let's go ahead and recompile my 149 here. Then I come out to here and I rerun this. Then I come into here. I should be able to see some differences of some pieces to get the subtraction done here. Let's go ahead and let's run this from command line and then rerun this. All right. So this subtract was not really used anywhere in here except for maybe this one. Yes. So this one is now different here because we're subtracting white minus cyan here and we're getting a different color here. This is what our output will look like. See, this is the expected output and this is our output. We still got some other numbers wrong in here, but we're getting closer to the output that we're expecting here. So at the end of the day, your output should match this particular page output inside of there. So just go ahead and complete that and turn in the pieces that are due into Autolab. I think it may ask for this output.html inside of Canvas. If you are asked for that, then you could just send this piece up and what you'll need to do is just file save as and just save this as the page source for the HTML as output.html and save that, like say to your desktop, or it should be actually available wherever you're running this piece. And over here, I'm running it on the desktop, so it'll be saved to the desktop. I can look at the new file and I can upload this. So that's basically all that I have here that I wanted to cover. So if you don't have any questions, I'm going to be around in office hours. I'm going to end this class meeting, and then I will go into the office hours meeting just so that I can start the recording mastering of that.